All right, so welcome to the deep dive, where we take a deep dive in some really interesting ideas.
Yeah.
And today we're talking about information density
hmm
and how that might be kind of the missing piece of the puzzle of like how the universe
That's
works.
exactly it.
And I'm really excited about this one because we've got a lot of sources, a lot of different perspectives, a lot of scientific papers, a
Mm.
lot of articles, and even some philosophical kind of thought experiments. So
Yeah, there's a lot to unpack here.
yeah. So what's the mission today? What are we trying to figure out?
Okay, so we're going to try to, I guess, distill the main ideas from all these sources and figure out, like, what is it about information density that seems to be so important? What does it tell us about the universe and our place in it?
I love that.
Yeah.
So one of the things that kind of jumped out at me from reading through all this stuff was this idea that everything in the universe, right, from the smallest particle to the largest galaxy, seems to be drawn towards regions of higher information density.
hmm
Like, what is that all about?
I know. It's a very strange concept at first, right? You think about information, it's sort of an abstract thing.
Hmm.
But the sources all point to this idea that information is somehow fundamental to the fabric of reality,
Yeah.
and that everything is kind of throwing in this direction of increasing information density. And they use this really cool analogy of like water flowing downhill. Water always seeks a more stable, denser state.
Okay.
And it's kind of the same with information. Everything in the universe seems to be drawn towards those denser information hubs.
So it's like the universe is constantly trying to become more informed,
Yeah.
more knowledgeable, more complex.
That's a great way to put it. And we see this play out on all these different scales, right? So you can think about something like a black hole.
Okay.
Black holes are like the ultimate example of information density, right?
Mhm.
They have so much mass packed into such a small space.
Yeah, they're like those cosmic vacuum cleaners that suck everything in, right?
Yeah, and so one of the key takeaways from these sources is that, black holes might not just be the end of the line.
Right.
They might actually be a crucial part of how the universe evolves,
Hmm.
how it recycles information and creates new structures.
Like the ultimate cosmic recycling program.
Right. Exactly.
That's a cool way to think about black holes. Instead of just these terrifying monsters that gobble everything up, they're actually like playing a role in this grand cosmic dance.
Yeah. And one of the things that kind of blew my mind about that was that black holes might not just be destroying information. They might actually be processing it and storing it.
Oh.
And that's where it gets really interesting, because then you start to think, well, what happens to that information? Could it be used to create new universes? Could it be, somehow transferred to other parts of the cosmos?
Okay. Yeah, those are some seriously big questions.
Yeah.
All right, but let's bring this back down to earth for a second. How does this information density idea play out in our own lives, like on a human scale?
Okay. Well, think about the growth of cities.
Okay.
So people flock to urban centers, right?
Yeah.
Because they offer more structured information, knowledge, technology, opportunities. It's all about increasing information density, even in our social systems.
So cities are like mini black holes of information.
Uh-huh. In a way, yeah. They
Mm.
concentrate information and resources, creating a more complex and interconnected environment. And then, of course, is the internet.
Right. The internet.
Oh, I'm talking about an explosion of information.
Right.
It's connecting billions of people and trillions of data points, constantly restructuring information at an incredible pace. And that's like a microcosm of the universe's self-organizing tendency, always pushing towards higher complexity.
So it's not just stars and black holes. It's like our cities and even our online world that are driven by this urge for more information.
Mm-hmm. Yeah. And it goes even deeper than that. These sources suggest that biological evolution itself is driven by this same principle.
Okay, what do you mean by that?
Think about it, right? From single-celled organisms to complex beings like us, life is all about packing in more information, more complexity, more interconnectedness. Each genetic mutation, each adaptation is like a step towards a more information-rich state. That's a better example. Constantly processing and structuring information to create consciousness.
So are you saying that evolution isn't just like random chance? It's
Mhm.
actually like directed towards this goal of greater information density.
I mean,
right?
that's one of the theories that's presented in these sources.
Okay.
And it's pretty compelling when you start to think about all the evidence that points in that direction.
Making me rethink everything I thought I knew about how the world works.
Yeah, it's pretty mind-blowing stuff, right?
Okay, so far we've talked about how everything is striving for more information, more complexity, but what about that whole entropy thing, the second law of thermodynamics.
Yeah.
Things fall apart, disorder increases. Doesn't that, like, contradict this whole idea?
That's a great question, and that's where things get really interesting. These sources aren't saying that the second law of thermodynamics is wrong, just that it's incomplete. They suggest that that we need to consider the role of information flow in counteracting that tendency towards disorder.
I'm all ears. Break it down for me.
All right. Think of it like this. You have a messy room.
Okay.
It gets messier over time, right? That's entropy at work. But what if you have a super efficient robot that can organize everything, find new ways to store things more compactly?
Yeah.
Suddenly, the room becomes more ordered, even though technically entropy is still increasing overall.
So the robot is like fighting against entropy by creating more order.
Exactly. The robot, in a way, represents this information density principle at work. It's taking something that seems disordered and finding ways to structure it, refine it into a state of higher information density. And this applies to everything from black holes to biological systems.
So systems aren't just like breaking down. They're breaking down and then reorganizing themselves into something new.
Yeah.
Something with more information packed in.
Exactly. And what we perceive as disorder might actually be a process of reorganization, a step towards a more information-rich state.
It's a pretty radical shift in perspective.
Yeah.
It makes you wonder if even, like, death isn't just an end, but a transformation into a new information structure.
Yeah.
It's a lot to process, but it's definitely making me think about things in a whole new way.
I know. It's kind of mind-blowing when you start to think about the implications of all this, right?
Absolutely.
Like, how does this change the way we view the universe, the way we view ourselves?
Totally. It's like seeing the universe with a whole new set of eyes.
Yeah.
And it makes you wonder if there's, like, a deeper purpose behind all of this, you know? Like a grand design driven by information itself.
That's a great segue to the next mind-blowing concept from these sources, and that is the idea that gravity itself might be a manifestation of information density.
Wait, gravity, the force that, like, keeps us grounded, what does that have to do with information?
Well, think about it. Mass distorts space-time. Right? Essentially encoding information into the fabric of reality. The more massive an object, the more it warps space-time. And the stronger its gravitational pull. So one way to think about it is that gravity is like a side effect of information being woven into the universe.
So you're saying gravity is like a symptom of information?
That's one way to think about it, yeah.
Wow. That's pretty wild. And it makes black holes even more intriguing.
Right.
Because they're not just points of intense gravity. They're regions of maximum information density.
Exactly. So you're starting to see how everything's connected. Black holes, gravity, information. It's all part of this grand cosmic dance.
This is, like, seriously blowing my mind right now. I need a moment to process all this.
Take your time. It's a lot to take in, but once you start to see the connections, it's hard to unsee them.
Okay, so let me try to sum this up. Everything is drawn to higher information density. Even gravity is a result of information being embedded in space-time, and black holes are like the ultimate information repositories. Am I getting it?
You're getting it. And it's just the tip of the iceberg. These sources dive into all sorts of mind-bending concepts, from the nature of time to the role of consciousness in shaping reality.
Okay, I'm definitely ready for more. But before we go down that rabbit hole, let's come back to the second law of thermodynamics for a second. We talked about it earlier, but these sources go deeper into how information flow challenges our understanding of entropy.
Okay.
So we know that entropy generally increases in a closed system, but these sources are suggesting that information flow and structure can actually counteract that tendency towards disorder. Like, what does that even mean?
It means there's hope for us yet, in a thermodynamic sense at least. So imagine if we could understand how to manipulate information flow.
Okay.
We might be able to design systems that defy entropy, at least locally. For example, imagine creating energy systems that actually become more efficient over time.
What?
Because they're constantly optimizing the way they handle information.
So we could create energy systems that actually become more ordered, more efficient, instead of breaking down. That sounds impossible.
It sounds impossible, but that's the potential, if we can understand and harness the power of information.
So you're telling me information is the key to, like, solving our energy crisis?
It's one of the possibilities these sources present. and it's pretty exciting to think about.
That's pretty mind-blowing. So if I'm getting this right, information is the key to everything, like from the workings of the universe to the future of technology.
That's a bold statement, but one that these sources argue is worth taking seriously.
Okay, I'm definitely on board. So where do we go from here? What are the next steps in like exploring this information density idea?
Well, the sources suggest a multi-pronged approach. We need to continue to develop our theoretical understanding of information. We need to conduct experiments to test these ideas in controlled environments. And we need to start thinking about the practical implications of all this. How can we use this knowledge to create new technologies, to solve global challenges, and to better understand our place in the universe?
I am so ready for this journey.
Me too. It's going to be a wild ride.
Buckle up, everybody. This is The Deep Dive. Welcome back to The Deep Dive. We're picking up right where we left off, delving deeper into this fascinating concept of information as the foundation of reality.
Exactly. We've explored some pretty mind-blowing ideas so far, but now we're going to get into the nitty-gritty, the scientific framework that underpins these concepts.
Okay, so we're talking like hardcore science now, equations and formulas. This is where I usually start to zone out.
Don't worry, I'll try to keep it as painless as possible.
Okay, good.
The key takeaway here is that these sources aren't just offering vague theories. They're proposing concrete ways to measure and test this connection between information and energy.
Okay, that makes me feel a little better.
Yeah.
So, like, how do we even go about quantifying something as abstract as information?
Well, one of the concepts that keeps popping up in these sources is something called Shannon entropy.
Shannon entropy.
Yeah, you mentioned entropy earlier in the context of thermodynamics, which is all about disorder, right?
Yeah, the whole things fall apart idea.
Right. But in information theory, entropy has a slightly different meaning. Think of it as a way to measure how much surprise or new information a system holds. The more unexpected the arrangement of things, the higher the entropy.
So, like, a random jumble of letters has more entropy than a coherent sentence.
Exactly. Because the jumble is less predictable, it contains more surprise, more potential information.
Okay, I think I'm following.
Good, and here's where it gets really interesting. These sources suggest that by structuring information in a more dense and coherent way, we can actually reduce entropy.
Wait, so instead of things always tending towards disorder,
Right.
we can actually create pockets of order, of lower entropy, by, like, manipulating information.
That's the implication.
Yeah.
It's like taking that messy room we talked about earlier.
Right, the robot room.
Exactly.
Yeah.
And organizing it in a way that maximizes information density. You're essentially creating a system that's more efficient, more predictable, and therefore has lower entropy.
So it's like we're hacking the system, finding loopholes in the second law of thermodynamics.
In a way, yes. And this connects back to the idea of the universe evolving towards higher information density. It's not just about cramming more stuff in, it's about structuring that information in a more efficient, more meaningful way.
So the universe is like a giant information optimizer, always striving for more elegance, more coherence.
That's a beautiful way to put it. And one of the sources takes us even further, proposing an equation that directly links energy to information density.
Uh-oh, an equation. I knew this was coming. Math is not my forte.
Don't worry, it's actually quite simple. E equals alpha times anything.
Oh, okay, you're going to have to break that down for me.
Sure, E represents energy, alpha is a constant, and I represents information density. So the denser the information, the more energy it can potentially release.
So things like black holes, which are thought to have the highest information density in the universe, could also be like incredibly powerful energy sources.
Exactly. Black holes as power plants. It's a mind-blowing concept.
It is. But how do we go from an equation on a whiteboard to actually harnessing that energy?
Well, it's definitely a long shot, but the theoretical potential is there.
Yeah.
And this equation has the potential to, like, rewrite the laws of thermodynamics as we know them.
Wait, seriously? How so?
Well, the second law of thermodynamics states that entropy always increases in a closed system, right? But if we can manipulate information to create order, to increase information density, then we're essentially counteracting entropy, at least in localized systems.
So we're talking about creating pockets of negative entropy, places where order and complexity actually increase over time.
That's a great way to put it. And those pockets of negative entropy could be the key to unlocking all sorts of technological advancements. Think about it. More efficient energy systems, perhaps even ways to manipulate biological systems to extend lifespan.
Okay, now we're getting into some serious sci-fi territory, but I like where this is going.
Yeah, it's pretty exciting, right?
It is. So if this connection between information and energy is real, What are the next steps in, like, turning this theory into reality?
Well, one of the sources suggests starting with small-scale experiments in fields like quantum computing and high-energy physics. By observing how information density affects energy flow in controlled environments, we can start to gather evidence to support this theory.
So it's like building the scientific foundation for a whole new way of understanding the universe.
Exactly. And once we have that foundation, the technological breakthroughs will follow. It's a long road ahead, but the journey promises to be filled with incredible discoveries.
I'm ready for the ride, but before we get too carried away, are we the only ones having these conversations? Is anyone else taking these ideas seriously?
You might be surprised to learn that there's a growing community of scientists, philosophers, and technologists who are exploring these concepts. It's still a fringe area of research,
Okay.
but it's gaining momentum as we learn more about quantum mechanics, information theory, and the nature of reality itself.
That's reassuring. It's good to know we're not completely out there on our own.
Not at all. And as this field of research grows, we can expect even more mind-blowing ideas and potential breakthroughs to emerge.
Okay, so we've been talking about all the potential benefits of this information as energy idea, but what about the downsides? Are there any risks or dangers we should be aware of?
That's a great question, and it's one that these sources don't shy away from. One of the biggest concerns is the potential for unintended consequences. If we start manipulating information at a fundamental level, we could inadvertently create systems that are unstable, unpredictable, or even dangerous.
So, like, we could accidentally create a black hole in the lab.
That's probably a bit of an exaggeration.
Okay, good.
But the point is, we need to proceed with caution. We need to develop safeguards and ethical guidelines to ensure that we're using this knowledge responsibly.
That makes sense. We don't want to unleash some kind of information monster that we can't control.
Exactly. And another concern is the potential for this knowledge to be misused. Imagine if this technology fell into the wrong hands. It could be used to create incredibly powerful weapons or to manipulate people's thoughts and behavior.
Okay, now that is scary.
It is something we need to be mindful of. But just because something has the potential for harm doesn't mean we should shy away from exploring it. Knowledge is power, and we need to understand both the benefits and the risks of this new frontier in science.
I agree. So it sounds like we need a balance of, like, scientific curiosity and ethical responsibility.
Exactly. We need to proceed with both wonder and caution, recognizing the incredible potential of this knowledge while also being aware of the potential pitfalls.
Okay, you've definitely given me a lot to think about. So, to wrap up this part of our deep dive, what are the key takeaways you want our listeners to remember?
Well, I think the most important takeaway is that information is not just some abstract concept. It's a fundamental aspect of reality that has the potential to shape everything from the workings of the universe to the future of technology.
Right. Information is power.
Exactly. And we're just beginning to understand how to harness that power. We've talked about how information density could be the key to creating more efficient energy systems, extending lifespan, and even manipulating time itself.
Okay, those are some pretty big claims, but you've presented some compelling evidence from these sources.
I have, and I encourage everyone to dive into these sources themselves and explore these ideas further. This is just the beginning of an incredible journey of discovery, and I can't wait to see where it takes us.
Me too. This deep dive has been an absolute mind-bender. I'm going to need some time to process all of this.
Take your time. These are big ideas, and it's okay to feel a little overwhelmed. But I hope you also feel a sense of excitement and wonder about the possibilities that lie ahead.
I definitely do. This is the kind of stuff that keeps me up at night, in a good way.
That's what we aim for here on the Deep Dive. We want to spark your curiosity, challenge your assumptions, and leave you with more questions than answers.
Mission accomplished. Thanks for joining us on this deep dive into the world of information density. We'll be back soon with more mind-blowing ideas and explorations. Until then, keep questioning, keep exploring, and keep diving deep. All right, welcome back to the deep dive. I hope everyone's had a chance to let those previous concepts really sink in, because we're about to explore some even more radical ideas that emerge from these sources.
Yeah, we've laid a solid foundation by examining the potential of information as the fundamental building block of reality, and now we're going to push the boundaries even further.
Okay, I'm ready for it.
All right, strap in.
Hit me with the next level of mind-bending.
Well, one of the sources directly challenges our conventional understanding of time, suggesting it might not be a fundamental aspect of reality, but rather a consequence of information flow.
Hold on, are you saying that time isn't real? Like it's just an illusion?
Not necessarily an illusion, but perhaps not as fixed and absolute as we typically assume.
Okay.
Remember, we've discussed how the universe appears to be evolving towards states of higher information density.
Right, like it's constantly upgrading its operating system.
Exactly. What if that process of information densification creates the arrow of time? The directionality we experience from past to present to future.
Okay.
Imagine time as a river flowing from a state of low information density to a state of high information density.
That's a really cool image. So the flow of information is what like propels us forward in time.
That's the idea put forth in one of the sources.
Wow.
And if that's true, it opens up some really extraordinary possibilities.
What?
For example, what if we could manipulate information flow in a way that affects the flow of time itself?
Okay, you're talking time travel now. Is that even remotely possible?
It's certainly speculative, but these sources suggest it's not entirely out of the question.
Okay.
If time is a product of information flow, then maybe by controlling information, we could influence its direction or even its pace.
So less about hopping in a time machine and more about like subtle shifts in the flow of time?
Precisely. It might manifest as slowing down the aging process or speeding up the rate of learning, time dilation, or compression, rather than outright travel.
Okay, I can sort of wrap my head around that.
All right, good.
It's still mind-blowing, but it's at least within the realm of like maybe possible.
Yeah, and that's what's so exciting about these ideas, right? They push the boundaries of what we thought was possible.
Absolutely. So what other groundbreaking ideas do these sources present? Because I have a feeling we're just getting started.
This is where things take a bit of a philosophical turn. One source explores the concept of consciousness
Okay.
and its potential role in shaping reality.
Consciousness. You mean like, or awareness of ourselves and the world?
Exactly. The source proposes a pretty radical idea. What if consciousness isn't just a product of the brain? What if it's a fundamental aspect of reality, interwoven with information and energy?
Wait, are you suggesting that our minds are literally shaping the universe?
It's a bold claim, but it aligns with certain interpretations of quantum mechanics, where observation is said to collapse the wave function,
Right.
influencing the outcome of quantum events,
Yeah.
the observer effect.
So like the universe is waiting for us to choose before deciding what happens.
That's one way to think about it. If consciousness is entangled with information, then our thoughts, intentions, even our emotions might be influencing the flow of information and energy that shapes reality.
That's a lot of responsibility.
It is, right?
Yeah. It's both exhilarating and a bit daunting to think we might have that much influence on the universe.
Exactly. It really changes the way you view your place in the cosmos.
Totally. It's not just about observing the universe, it's about participating in its creation.
Right. And that brings us to the end of our deep dive. And I want to leave you with one final thought to ponder.
Okay.
If information is truly the fundamental essence of reality and our consciousness is intertwined with it, what does that mean for our understanding of life, death, and the meaning of existence?
That's a profound question, and honestly, I'm not sure I have an answer. But it's definitely something I'll be reflecting on for a long time.
And that's really the point of these deep dives, right? It's about sparking curiosity, challenging assumptions, more than arriving at definitive answers.
Yeah, it's about expanding our minds and exploring the mysteries of the universe and ourselves.
Exactly. And I think we've done a pretty good job of that today.
I agree. This deep dive has been an incredible journey. Thank you so much for guiding us through these mind-bending ideas.
Well, thank you for having me. It's always a pleasure to dive deep into these topics with you.
And to our listeners, thank you for joining us on this exploration of information density. We hope you've enjoyed the ride.
We'll be back soon with more mind-blowing ideas and explorations. Until then, keep questioning, keep exploring, and keep diving deep.